Welcome to Algebra, Arithmetic Sequences. Pattern recognition is an important aspect of any problem-solving process, and algebra is no different. Two commonly occurring patterns are referred to as arithmetic progressions and geometric progressions. This lesson will explore the first of these two sequential patterns. Arithmetic progression is a sequence of numbers in order, in which the difference between any two consecutive numbers is a constant value. It is also called arithmetic sequence. The formula for this is a sub n equals a sub 1 plus parentheses n minus 1 times d. A sub n represents the nth term in the sequence. A sub 1 represents the first term in the sequence. And d represents the common difference between any two terms. Here is a sequence of values. Do you see a pattern in this progression of numbers? If you thought each number is 4 more than the previous, you are correct. The value 4 is called the common difference, and in the formula is represented by the variable d. Let's try another sequence. Do you see a pattern? If you thought each number is 2 less than the previous, you got it. The value -2 is the common difference. How about this one? Do you see a pattern? The pattern changes. The difference between the first two pairs is +2, but the next one is +3. This is not an arithmetic sequence. Let's do one more. This does show a pattern with the value -3 as the common difference. What would be the next three values? If you thought -17, -20, and -23, you would be correct. What would be the next three values for this sequence we looked at earlier? If you thought 17, 21, and 25, you are correct. And this pattern? Continuing the sequence, you get 0, -2, and -4. Let's look more closely at this formula for an arithmetic sequence. We've identified the variable d as the common difference +4 in this pattern, and so we substitute 4 in place of d. The variable a sub 1 represents the first term in the sequence. The variable n represents the nth term in the sequence, so if n is 3, the third term in this case would be 9. We work out the expression on the right side. 1 plus 3 minus 1 times 4 becomes 1 plus 2 times 4, or 1 plus 8, which is 9, and the formula works out. For this pattern, the variable d is the common difference -3, and so we substitute -3 in place of d. The variable a sub 1 is the value -5. Let's choose 6 for the variable n representing the value -20 in this case. A sub n equals a sub 1 plus n minus 1 times -3, the common difference. Then we replace -5 in place of a sub 1 as the first term. N is now 6. We work out the right side, and we get 6 minus 1 is 5. 5 times -3 is -15. And then -5 plus -15 is -20. And again, the formula works out. To find another term farther down in the sequence, such as the 8th term, we use the formula instead of continuing the sequence one value at a time. A sub 8 equals -5 plus 8 minus 1 times -3. A sub 8 equals -5 plus 7 times -3. 7 times -3 is -21. -5 plus -21 is -26. And so the 8th term in this sequence is -26. Now you can see that pretty obviously by taking -23, subtracting 3, and you get -26. So it proves itself. The formula works. What if we wanted to know the 20th term in the sequence? Simple. Just use 20 for the value of n and work out the expression. A sub 20 equals -5 plus 20 minus 1 times -3. 20 minus 1 is 19. 19 times -3 is -57. -5 plus -57 is -62. And so -62 is the 20th term in the sequence. Let's work out the rule, or function, for this pattern by simplifying the formula for the nth term. A sub n equals negative 5 plus n minus 1 times negative 3. We distribute the negative 3, and we get negative 5 minus 3n plus 3. We combine the negative 5 and 3 to make negative 2. And so our formula, our function, our rule, is a sub n equals negative 3n minus 2. We replace n with 20, and we get negative 3 times 20 minus 2. Negative 60 minus 2 is negative 62, which matches what we just did in the previous slide. Here's a pattern we haven't yet examined. Let's work out the rule, or function, for this pattern by simplifying the formula for the nth term, and then find the 19th term. The common difference here is plus 3. We replace d with 3 in the formula, and now we have a sub n equals negative 11, the first term, plus parentheses n minus 1 times 3. Simplifying the right side expression, we get negative 11 plus 3n minus 3 after distributing the 3, which combines into 3n minus 14. And so our formula, our rule, our function for this sequence is a sub n equals 3n minus 14. We replace n with 19, and we get 3 times 19 minus 14. 3 times 19 is 57. 57 minus 14 is 43. And so now you can see how the formula for the arithmetic progression works.